let me write step 1. So here we have that the Old Farmer's Almanac stated that the average consumption of water per person per day was 123 gallons. To test this hypothesis that this figure may no longer be true, a researcher randomly selected 16 people and found that they used on average 119 gallons per day, and the sample standard deviation is 5.3. At alpha equals 0.05, is there enough evidence to say that the Old Farmer's Almanac figure may no longer be correct? So for the null hypothesis and the alternative hypothesis, I would like to have some assistance. So mu, you got to tell me what you're going to do. Mu equals 123. Mu is not equal to, glad I got that one right, plus 2 for me. So step 2 is to compute the t-test statistic. Oops, I gave it away, didn't I? To compute the test statistic, which one is it? T or the z? And why is it the t? Because we have a sample size of 16, and we also have a sample standard deviation. Yeah.
Is that for your alternative? Is that a 125 or 123?
It looks like it's written as 125, doesn't it? Well, think. Huh? No, that was a typo.
Oh, okay.
Because that's what I got on my paper.
So on my test, I can say that was a typo. I remember that.
You can give it a whirl, my dear. Feel free.
My head's red. Come on.
Yeah, sure. So we take x bar of 119 minus mu under the null hypothesis, which is 123, times the square root of our sample size, which is 16, divided by 5.3. So I came up with negative 3.02. So for step 3, step 3 in this case is compute the p-value. So again, we can draw a t-distribution, and we have our t-test statistic at negative 3.02. So it's going to be 3.02, negative 3.02, or this way. But since we have a two-tailed test, we also have to go 3.02 and up this way. So we know we're going to have to compute the p-value and double it, right? Because it's a two-tailed test. So to compute the probabilities using the t-distribution, we'll go 2, because since we have to double it, we may as well go stick the 2 in there, times, and then if we go to second distribution, menu option 5 says TCDF. So let's choose menu option 5, and since this is a TCDF, this works the exact same way as the normal CDF, except we have to add one thing to it. So it's going to be TCDF, it's going to be lower bound, upper bound, and then we have to give it the degrees of freedom. That's the difference between this one and using the standard normal. So our lower bound, so I'm just going to compute for this lower tailed area since I've already got the doubling in here. So I'm going to compute this area just for the left tail, and then we've got the 2 multiplier up here already. So the lower bound is second, negative second infinity, comma, and the upper bound is negative 3.02, comma, and our degrees of freedom is going to be 15. Then we just push the magic button, so we end up with 0.009. Or, since this is probability, I think we've been just kind of using a standard 4 decimal. So here we have that our p-value, so here we have a p-value of 0.0086. I believe that's what it was. Yeah, 0.0086. So now, step 4, we have to make a decision. And remember, with our p-values, we make our decision by comparing 0.0086, and we want to compare that to 0.05. So is 0.0086 going to be greater than or less than 0.05? Less than. So since our alpha level, since our p-value is smaller than our alpha level, what is our conclusion? We reject the null hypothesis. So since we're rejecting, we can come back and we can basically say that the Old Farmer's Almanac is no longer correct. That's basically what we're saying.